going to talk about how to convert measurement units, like feet to inches, inches to feet, ounces to cups, and all the good stuff. So the ratio of boys to girls is 2 to 3. So let's review what we learned how to solve prediction and comparison problems. The ratio of boys to girls is 2 to 3. I'm going to draw a picture to help me out. So 2 boys, 3 girls. There are 1,200 students at McMeans Junior High. So if we're going to keep this ratio, how many boys attend McMeans Junior High? So it's asking how many boys attend McMeans Junior High out of 1,200 students. So it's about the labels will be about boys and students, not girls and students, or boys to girls, boys to students. So according to this ratio, there are 2 boys out of how many students in the set? 5. So if I continue the pattern to 1,200 students, how many boys will be from 5 students to 1,200 students? So I could sit there and keep guessing how many 5s go to 1,200. But you know what? I'm going to build up slowly. I'm going to build up by, I don't know, 20. That would be 140. Now I'm going to build up from 100 to 1,200. I multiply by 12. So that would be 480 boys out of 1,200 students. But if you really want to do it in one shot, how many 5s go to 1,200? Let's see. It goes in 240 times. So you got built it up by multiplying by 240, multiplying by 240. Eventually you get 480 boys out of 1,200 students. So many ways to do this. You can build it up slowly or build it up in one shot. So let's look at this chart right here. This is a number line. What does an ordered pair from this graph represent? So let's look at an ordered pair. So what ordered pairs do you see? I see 12 and 1. I see 24 and 2. And I see 36 and 3. So what do these numbers represent? Let's look at our label. What's the label of the x-axis? It represents a length in inches. And then the y-axis represents length in feet. Oh, I get it now. There are 12 inches in 1 foot, 24 inches in 2 feet, 36 inches in 3 feet. Now that makes sense. So write the rate as a unit rate. So what is the definition of unit rate? The denominator got to be 1. So it's per 1 unit. Oh, so 12 inches per 1 foot. So every foot there are 12 inches. Now explain how could you use the graph to determine the length in inches of a 2.5 foot iguana. Let's see, foot is on this side, so 2.5 would be right here. How many inches will that be? 30 inches. A 2.5 foot is the same as saying 30 inches. However, you can use the ratio table and proportion to figure this out without using a graph. So to convert measurement units, the conversions can be written as unit rates. For example, on your pink paper, you're going to receive a pink paper that says grade 6 mathematics reference chart. It has all the different units and their equivalencies. 1 mile is 5,280 feet. You can use the unit rate 5,280 feet over or per 1 mile to convert different problems about feet to miles or miles to feet. So let's try an example. I'm not going to do bar diagram. You notice the bar diagram disappeared. So we're just going to do rate tables or ratio tables and using proportion. So the average weight of a baby at birth is 7 pounds. Oh, wait. I didn't read the whole question yet. How many ounces is the average weight of a baby? So use unit rate. Looking at your pink chart, I wish I had one here to show you right now. What can you say about pounds and ounces? It says 16 ounces make 1 pound. We don't have to label it. It's already been labeled right there. 16 ounces make 1 pound. However, we need to figure out how many ounces there are in 7 pounds. So we need to build it up. I build it up by multiplying by 7. So 16 times 7 is 112 ounces to 7 pounds. And that is our answer. If you don't like ratio or rate tables, we can set up through a proportion. So what is this about? They want to know how many ounces in pounds. So pounds, so ounces and pound, ounces and pound. So we know there are 16 ounces in 1 pound. The baby weighs 7 pounds. How do you build up from 1 pound to 7 pounds? You multiply by 7. Multiply by 7, you get 112 ounces per 7 pounds. Same thing, proportion. Again, what is proportion? It's when you have two equivalent fractions or ratios or rates. They're equivalent. So 16 ounces, 1 pound is the same as saying 112 ounces to 7 pounds. All right, the tunnel is 2 3/4 kilometers long. How many meters is the length of the tunnel? So, oh, they forgot to label it. How crude. So we know, if you look at your pink paper about the measurement, by the way, you'll get that during STAR test. You don't have to memorize them, because I don't memorize them. Actually, I have. It's teaching too long. So I'm going to do meters and kilometers. Why, you might say, I'm using this? Because they want to know how many meters is this kilometers. So according to our, there are 1,000 meters for every 1 kilometer. That's my unit rate. I would like to know how many meters there are for this 2 3/4 kilometer. So let's build it up. Can you build 1 to that? Yes, you can build it up. You have to multiply by 2 3/4 to figure out how many meters. Oh, it's multiplying fraction again. Yay. So it's 1,000 over 1 times 2 3/4 is the same thing as saying 11/4. If you multiply the numerators, you get 11,000 over 4. How many groups of 4 go into 11,000? I do not know. I shall find out. 7, 28 is 2, 5. 2,750 meters is the same as saying 2 3/4 kilometers. Think about it. For every 1 kilometer is 1,000 meters. So 1 kilometer is 1,000. 2 kilometer, 2,000. 3/4 is the same thing as saying 75. 750. Some people can do it in their head. So if you do not like ratio table, you can set up a proportion. So what are the labels? The labels are meters and kilometers. Meters and kilometers. We know 1,000 meters is the same as 1 kilometers. So how many meters are in 2 3/4 kilometers? We have to build up from 1 kilometer to 2 3/4 kilometers. So I'm not going to redo the problem because I just did it. 1,000 times 2 3/4 is the same as saying 2,750 meters. So what we did is we set it up as a unit rate, and then we just built up to our answer. Sometimes you have to break it down. And will it be this example? I don't know. So in this example, it's about recipe for ice cream calls for 1.75 liters. How many millimeters is this? So it's about milliliters and liters. Looking at your reference chart, what does this say about? 1,000 milliliters is 1 liter. Before some of you say, why don't you label it liters and milliliters, Mr. Joe? Remember, writing as unit rate, the 1 needs to be in the denominator. Oh, yeah. So can you build 1 liter to 1.65 liters? To build it up, you multiply by 1.65. Gosh, multiplying fractions, multiplying decimals. What else does he want us to do? Sheesh. So it's 1,000 times, remember, we'll come back and look at this decimal point. So you have 0,005, put a placeholder here. Hello. You have 0,006, 2 placeholders here. They're grumpy because they're tired. 0, 0, 0, 1. So, whoa. Is the answer going to be 165,000? Of course not. Where's our decimal point? It's two places. So it's 1,650 milliliters for every 1.65 liters. You know, I could have done it without doing all this math. Think about it. If each liter is 1,000, 1 liter will be 1,000, so 65. It's a decimal part. I knew it was going to be 650. Again, you can set it up like a proportion. Same way, just make sure you know your labels. So it's milliliters over liters, milliliters over liters. We know 1,000 milliliters, 1 liter. And we know we have 1.65 liters. How do you build up from 1 liter to 1.65 liter? You multiply by 1.65 liters. And we already did already, it's 1,650 milliliter. So 1,000 milliliters to 1 liter is the same as 1,650 milliliters to 1.65 liters. All right, I'm gonna skip. I don't know. I'm just gonna do this question right now. This one right here. Adam made a pot that contained 273 ounces. He served his guests in 1-cup bowls. How many ounces will he have left over? Because I guess they're not going to be using. So from what I could tell, the units are ounces and cups. Looking at your mathematics reference chart, what does it say? It says 8 ounces make 1 cup. 8 ounces make 1 cup. There are 273 ounces. And we need to figure out how many cups are those. So can you build up? How many 8s go into 273? You can estimate 8 times 20. It's 160. Too low. 8 times 50. That's 400. Too high. I'm not going to sit here and guess. I'll be here forever. And I always wonder if there's a time limit on YouTube videos. So you know what? Instead of me guessing, I can do this. How many groups go into 273? It goes in 3 groups. 3, I bring it down to 3. How many 8s go into 33? 4 times. So it's 34 and 1/8. 34 and 1/8. So what is 1 cup? Because you're building it up by multiplying by 34 and 1/8. So it's 34 and 1/8. 273 ounces is the same as saying 34 and 1/8 cup. Again, the question is asking what? How many ounces are left? How many remain? You can make 34 cups, but I want to know how many's left over. 1 ounce is left over. So that's a trick question. I can see kids are saying, oh, the answer is 34 and 1/8. By the way, the decimal was 34 and 125,000, if you really want to know. But the question they're asking, how many ounces are remain? 1 remains. And that's about it. So in the study of turning units and converting measurement units, it's all about proportion. Either setting up ratio tables or using proportion. You just have to make sure you have to God, units are so important. You got to know what units are you going to write down. Will it be ounces of cups? Then you look at your mathematics chart, figure out, fill in the numbers, and then you build up or you break it down.